Alright, so good afternoon. So today we'll be looking at reactions of organic compounds. Alright, so let's start with the alkenes. Alright, so we know that alkenes are saturated compounds. So it's CnH2n plus 2. Alright, so it is C single bond C. Functional group. Right? So now, because they are saturated compounds, they hardly undergo chemical reactions, right? So they are basically inert in a sense, right? So for alkanes, two reactions you should know about, right? One, combustion reaction. Alright? So all organic compounds will undergo combustion reaction. So whenever you are asked in the exam to do reactions of a compound, it's an alkane, alkenes, alkyne, carboxylic acid, or alcohol, they all will undergo combustion. So they will all burn in oxygen. So an example, smallest compound, we can use CH4 gas plus oxygen gas. And they will produce carbon dioxide plus water vapor. So remember in combustion reaction, because combustion reaction will be like you light cooking gas and it's reacting with the oxygen in the air and you can see the flame, it's burning, right? So it is what we call an exothermic reaction. That means that reaction is giving off heat. So that is why when we should start the reaction, it will continue to burn until the gas is finished, because we know that oxygen in the air is not going to finish. So whenever the cooking gas or whichever fluid we are using, gasoline in the car, is used up, then the reaction will stop. But as soon as we ignite it, it will continue to react because it produces energy. Alright? So how do we balance this equation? So one carbon, one carbon. So we are going to save the oxygen for last, right? So next we are going to balance the hydrogen. So we have so we balance carbon first, then hydrogen, and the oxygen last. Alright? So we have 4 hydrogen over here, we need 4 hydrogen over here, so we put a 2 here. Now we have 2 oxygen, following my Pauline, 2 oxygen here, and 2 oxygen here make 4, so we put a 2 here. Alright, and this is a gas, so we're on a gas here. Alright? So for this, sometimes in organic chemistry, or most times in organic chemistry, they want to know the condition for the reaction. Alright? And they just point to know, like the alkanes, they normally tend to burn with a clean flame. Just for example, look at the cooking gas, you can see that it's not like smoky, like for example some diesel engine, that the engine is bad and it's actually have like a smoke looking stuff, or if you're burning garbage outside, you will see how the flame looks smoky because it's would be a mixture of compound, which would include like the plastics or like unsaturated compound like the alkenes, a mixture, right? But if it's pure alkanes, they tend to burn with a clean flame which does not smoke, and it's very nice. Reactions of alkenes, they undergo substitution reaction, right? So for example, if we have, let's write out this one, right? I'm deliberately writing, but you can see that this is the same methane as this, right? Just this is the full structure, this is the molecular, alright? So if you should react this with a halogen, so you can be bromine, chlorine, iodine, right? They will all substitute. So put a halogen here, right? So this is the general formula I'm going. This will produce haloalkane plus the hydrogen halide. Right? And so this is general, now example. So here, if we go in general, we should be alkenes here. right? So I put in the general formula. So when I say halogen here, halogen is either chlorine, bromine, or iodine. Alright? Reason I'm doing this is that in the exam I might use chlorine here as the example, but in the exam they might give you bromine or iodine, which is the same principle. Alright? And just know that chlorine tends to be yellow, bromine is brown, iodine is dark, the color. Grayish purple for the iodine. Alright? Dark color, grayish purple, similar. Alright? So what happens is that whenever we should, and we know that the alkanes are colorless. Alright? Right? So if we should react this with like a colored halogen, then after a while you will see that if we should put it in the dark, no reaction will take place. But if we put it in UV light, so that is why this requires light. And specifically UV light. So this reaction, if we should have it in the dark, no reaction will take place. Alright, because substitution is what we call a free radical reaction. And it needs light as to provide the energy, the activation energy, right? And in energetics you will learn more about that, right? So if we go CH methane plus Br2 in liquid, right? So this, for example, if you have it in bright light, the reaction will go quickly to form CBr plus 4HBr, right? And this will be liquid, this gas. Yes, right? No, because they only need to test if you know the principle, alright? And remember that this reaction will take place in light, right? However, if the light is not bright, so put bright light here. Bright light. You see, if we have dim light, sometimes only one of the hydrogen will be substituted. Clear? So it does not have to go all the way, or initially it do it step by step. So it will remove one hydrogen first, then to form the CH3Br. And then it will remove another hydrogen. So you have to know that it will do step by step. So sometimes in the alkene, so one combustion. So example, smallest alkene would be C-double-bond-C. But if we go, the general formula is alkene plus oxygen gas, which is O2, produce carbon dioxide plus water vapor, right? Just be specific to know that in those reactions when you are burning an organic substance, the water that is produced as the byproduct is actually in the gaseous form because that temperature will be above 100 degrees Celsius. Right? An example, C-double-bond-C. So we're using ethene as the example, right? So this is 2 carbon, ene for alkene. Clear? Plus oxygen gas will produce carbon dioxide gas plus H2O gas. So remember that in combustion, the water that is produced there is in the gaseous form. Right? How do we balance this equation? Remember that we're looking at reactions of organic chemistry, right? We did the alkanes already, which is just 2 reactions, the combustion and the substitution. And now we are doing the alkenes, which is basically the combustion plus all the addition reactions that I will show you as we go along. Okay? How do we balance this equation? So remember, we balance carbon first, then hydrogen, and then oxygen. General principle we balance in organic combustion reactions is the carbon first, then the hydrogen, and the oxygen we save for last. Right? So as we can see, we have 2 carbon here, So we got 2 in front of the carbon dioxide, 2 carbon over here, right? Then we have 1, 2, 3, 4 hydrogen. We have 2 here, so we'll have to put that 2 here as well to make 4 hydrogen. And then if we check, we have 2 oxygen plus we have 2 2 is 4, so it's 6 oxygen in total. So 2 times 3, 6. Broad category, so addition. So we have like A, B, halogenation, you know what halogenation is? A chlorine, bromine, iodine. We can add it across the double bond. We can also have hydrogen across the double bond in hydrogenation, right? So this is C. So hydrogenation is H2 gas we add in. So I'm just writing in bracket the molecule that will be added. In halogenation, it will be Cl2 or Br2 or I2, the halogen. There? While C is addition of hydrogen halide. So we have H, Cl, or HBr, or H. So either hydrogen chloride gas, hydrogen bromide gas, or hydrogen iodide gas can be added across the double bond. Then we have D is hydration. That's basically adding water. Oxidation, right? Oxidation, and oxidizing agent before we reach the redox reaction is a hardening. Even though we haven't studied redox reaction, you have to know about 2 types of oxidizing agent. KMNO4. Right. So, right, in addition, even though that's going to be a separate class by itself, is polymerization. A, C, D, E, F. But F is a separate class by itself. Polymers. Alright, but just to note that alkenes will allow polymerization. So it's basically alkenes reacting with alkenes to form long compounds. Polymers are plastics, alright? Alright, so let's look at examples of each plus the condition that is required. And remember that we're going to use ethene as the example, but it can be any alkenes. They could be propene, butene, pentene. But we're just going to use ethene for simplicity. Alright, so 2 major types of reaction, the combustion and the addition reactions. And you can see the addition reactions are really broken down into several different types of addition reactions. So basically addition reaction, 2 molecules coming together to form one larger molecule. Alright?